So in this video, we're going to start to look at the confidence interval, and especially when we know the population standard deviations value. In our next video, we're going to look at confidence interval again, but it's when the scenario when we don't know the population standard deviation. Okay, so before we start introducing the confidence interval, we want to calling out another estimate called the point estimate. So the sample mean x bar calculated from the random sample from x1 to xn is considered as called a point estimate of unknown population mean mu. So when we think about point means a dot. So it is an estimate because it is the value of the estimator x bar, right? So we consider it as a point estimate. It's one because it's a one statistic, right? So another way to estimate your population parameters is using called the confidence interval. It's called a confidence interval estimate. So it's construct a confidence interval for unknown mean by adding and subtracting a margin of error from x bar. So that's another way to estimate your population parameter. So why this is important? Because as we learned, the x bar is a random variable, right? So because it depends on each time you sample, how you sample, so they have a variation. So when we are calculating the expected value of the x bar, we only got a data point. So that is the center, right? But as we know, that is not always the case. That not always will be the value you're always going to be able to get if you're getting a sample. Now, instead of just say, hey, this is the estimate, we're looking for, hey, if we have certain confidence, given that confidence, what will be the potential range for my population value? Okay, so that is the confidence interval. So as we calculate confidence interval, you need to know that called the marginal of error from x bar. Okay, marginal error from x bar. So remember now we're introducing two things. Now one is called the standard error of the mean, right? So here we're looking at called the marginal of error from the mean. Marginal of error from the mean. So we're using the marginal of error from the mean to calculate the confidence interval. Okay, confidence interval. So how can we do that? So the confidence interval of the mean with a known sigma. Okay, with the known sigma, we are using the following formula. Okay, so we are using the sample mean x bar plus minus the z statistic times sigma divided by square root of n. Remember, we already learned sigma divided by square root of n is the standard error of the mean. So basically using the z value times sigma divided by square root of n, we call it marginal of error from. So that is called marginal of error. So the marginal error is consisted of two parts. One part is the z value. The second part is my standard error of the mean. So standard error mean times the z value give us the margin of error, and we will need this margin of error to calculate my confidence interval. Some students say, hey, Dr. J, I think this formula just look like the formula we saw in the previous video, the range of the mean, of the sample mean, right? So the answer is no. Let's show you the difference. So this formula is x bar plus minus z times sigma divided by square root of n. If you look at the previous one, we're using the mu plus minus z statistic z value times sigma divided by square root of n. So the mean difference is whether you're using the mu or x bar. So in the statistics world, although you end up using the same number, and the notation are still different now because the purpose are different. Remember the expected range of the sample mean. Here we are trying to understand the sample means distribution. So therefore we are using the population mean. We're using mu. But here when we look at confidence interval, confidence interval we're looking for here is for confidence interval for my population mean. Okay, so therefore we base on the sample mean and then to obtaining this confidence interval. Although I want to call out, practically when we work on the mathematical calculation, you will notice that we actually just use mu's value. Why is that? Because we already mentioned x bar is the unbiased, most efficient, and the consistent estimator for mu. So therefore, mu equal to x bar equal to mu. So here we just want to use x bar to denote that we are looking for this confidence interval. It is for the mu. So confidence interval for the mu. Therefore, we are not using the mu again. We're actually using the x bar. But again, when we look at the example, you will notice we'll literally just use mu's value here. Okay. Now let's explaining a little bit about our z values, because we in the last video we just talked about, hey, z value equal to 1.64, etc. Right? We didn't explaining, hey, what is this z values? So let's look at what is z value we needed to calculate my confidence interval, right? The margin of error. If the sample are drawn from the normal distribution, and or if the sample is large enough that x bar is approximately normal by the central limit theory, and the sigma is known, so the population standard deviation is known, then the margin of error is calculated using the standard normal distribution. The value of the z statistic is determined by the desired level of confidence, which we call it 1 minus alpha. Because the sample distribution is symmetric, and you are able to see this normal distribution, and so we are using half of the alpha is the area in each tail of the normal distribution. Okay, before I go further, let me explain a few things from this statement. So the first is about, hey, what is called desired level of the confidence. So let me go back here. When we look at the range of the sample distribution, we're talking about 90%, 95%, 99%. So that is desired level of the confidence we're going to use here. So we have 99% confidence, or we have 90% confidence, we have 95% confidence. As you can see, as you are increasing the level of the confidence from 90 to 99, you get more and more confident, right? I have 100% confident, you know for sure that's going to happen, right? So therefore, that level of the confidence turn to be close to 100, because the larger, close to 100, the more confident you are. You don't want to say, I only have 5% confidence, so that's like, oh wait, you're not confident, right? So the level of the confidence is close to 100. And here, the level of the confidence has a relationship with this alpha we are talking about here. So the alpha actually has a name called a confidence coefficient. So the confidence coefficient is different from the confidence level, okay? So the confidence coefficient is equal to 1 minus confidence level, okay? Or the confidence level equal to 1 minus my confidence coefficient. So the alpha itself tend to close to 0 side, okay? So the confidence level close to 100%, and then the alpha, since it's 1 minus alpha equal to level of the confidence, therefore the alpha is close to 0%. So don't get confused here. Okay, after you know the relationship between level of confidence and this confidence coefficient, now we can start looking at this diagram together. Okay, so there's normal distribution. As we already learned in the chapter 7 about the normal distribution. Normal distribution is symmetric, right? So normal distribution is like symmetric. If I draw a line here, since I'm using z here, that means this is the standard normal distribution. And the standard normal distribution means if I find my peak, that's where my symmetric line here is. So the value here will equal to 0, right? So for the standard normal distribution, and your center will be at this vertical line equal to when z equal to 0, okay? Okay, z equal to 0. And when we're looking at this alpha, the alpha is looking at the size of the area, okay, the size of area. So when we're looking for, let's say, I'm going to using a 95% as the example, okay? So when we look at the 95% confidence interval, what does that mean is the probability of a value falling to that range equal to 95%. So this with the 95% confidence means the area here equal to 95%. Okay, 95% is this area. Okay, so this whole area is the size of the area equal to 95%. So what the left is the leftover will be 5%. So basically, if we adding this two shaded area together, it will give us the rest 5%. So the size of area. But when we're looking at the z alpha divided by 2, what we are looking for is the z value on this horizontal axis. So basically, we are trying to identify, hey, given I have 95% confidence, which is here, what should be the value of here? Okay, what should be the value of here? So the value of here is the z alpha divided by 2. Okay, we are using the value of here because that's when we are able to achieve 95% confidence interval, right? So once we know the z-scores value here, we are apply this to our to calculate our calculate the margin of error. So that is the z alpha by 2 is the value on this horizontal axis. What's this dots value equal to? Okay, so again, here we try to explain how that works, right? So once we work on the practice questions, and hopefully this is going to help you understand how we get at z scores. But pretty straightforward is that once we use Excel, it's very easy to calculate z alpha by 2. Okay. Okay, so here we want to look at the confidence level versus, as we mentioned before, we have 4 ways to causing the variation of my sampling error, right? So this is one of the level we can control called the confidence level. So a higher confidence level leads to a wider confidence interval. Think about that, right? So 99, if you go back to think about this diagram, okay, so 90%, the area, this is this wide. When we look at the 95%, it becomes wider, right? So therefore, the higher confidence level, you're gonna have wider confidence. So that also means your z statistics value will become larger. So the greater confidence implies loss of the precision. That is the greater margin of error. So 95% confidence is most often used, and sometimes we also use 99% and 90%. So 90% we will have the narrower, shorter confidence, narrower compared with 95%, compared with the 99%. So 99% confidence is the widest. Okay, so as you can see, my z statistic value getting wider, larger and larger because the larger of the margin of error. Okay, marginal error. Okay, so next we're gonna look at how should we interpreting our confidence interval. So confidence interval either does or does not contain my population mean. So the confidence level quantify the risk. Out of the 100 confidence intervals, approximately 95% may contain the mu, while approximately 5% might not contain the mu when construct 95% confidence intervals. So note that one interval does not contain the mu, right? So you can see here, this one does not contain my population mu. As you can see, this is the end. And for this one, it does not contain my population mu. So basically, the confidence interval we are calculating here is try to look at with the confidence, with my 95% confidence, what is the range of my mu may be included. So now, as we said, we are assuming it's follow normal. So if the sigma is known and the population is normal, then we can safely use the formula to compute the confidence interval. And if the sigma is known and we do not know whether the population is normal, and we need to make sure the sample size is at least 30, and in that situation we can and then we can use the formula, and if we know there is no outlier and all the distribution is symmetric. And the larger sample size will need it to assure it's a normal distribution if we have some population is very skewed. So basically here is application of a central limit theory, right? Okay, so before we move on to the next lecture, and please move on to the computer skill where we are going to look at an example in terms of how to calculating the confidence interval when we know the sigma value and using the Excel.